So now we will do a Trumpf program. The Trumpf uses the same software but is completely different in how we tool it up. So we'll start Metacam, hit OK. We will import a DXF. We'll use the same one that we used for the laser. Do nothing here again. Hit OK. And so we are still in the laser post-processor, so we need to change this. There's a quirk to this in that you go to part settings, defaults, load by name, and click on Trumpf, hit OK, load all settings. When you go to tool this, it gives you an error and closes for whatever reason. Let's see. So yeah, as soon as I went to go select a tool, and I think the reason for it is it still thinks this is laser, but then we have the Trumpf, so it's got conflicting data. So essentially it needs to reload. So if you just hit terminate, it'll just close Metacam out. So now when you open it, re-import that DXF file. So we use the same one again. Hit OK. Now it says punch tooling. You click on that, you can see the clamps of the Trumpf. And now when we hit it, it'll actually bring up our tool library. So once you bring this in, you just need to close it out, reload it, and everything's good. It'll be fine. So we don't need to do anything with this part. We'll do the wire joints in the tooling section of it. So we're good with this. So first thing you need to do, same thing, go here. You want to be machine is the TC500R. Materials mild. Thickness, we'll do 060 again. Sheet size, the Trumpf will do up to a standard without a sheet shift. It'll do a 5x10. It will actually do a longer sheet than 10 feet wide, or 10 feet long rather. We haven't done that, but it has the capability. The Trumpf is different in the margins. Left, top, and right are all 1/2 inch, and then the bottom is 3.5 inch. The reason for that is there is a no punch zone 3.5 inches from the edge of the sheet, and the reason for that is so the machine doesn't actually punch through one of the clamps. So this should load up in the default, so you can just leave it. Everything else should be, you shouldn't have to change any of this. You can change the position of the clamps. So for whatever reason, there's something special where, like, you have a shorter sheet, a special size pre-cut sheet, you can actually go in here and change the position of the clamps. But otherwise, just hit done. And so now we are ready to tool this part. So manually place tool icon. It will bring up our tool library. This is what the software thinks is in our turret. These are kind of the mostly used punches. And then if you click on the tool library tab, these are all the tools that we have entered in so far. And so the first one we're going to do is the radius. So 1/4 inch radius. This part has 1/4 inch radiuses on all 4 corners. So right now the tool won't do anything. If I place this tool, it's not going to turn, it's not going to do anything. So if I right click, and now you can see I can pick a corner or a point of origin for this tool. So how do I want to do this? So for this radius, I'm going to left click the midpoint of this radius section. And so now when I go to a radius on the part, it will actually automatically turn the tool. I don't have to do anything to it. So we start here, and you can see when it lines up to the midpoint, you can left click this and it will place the tool. So here, left place that, place that, place that. So now we have all of these in line. So next step, let's do the circles. I think these are 1/4 inch circles. So again, in our turret, we have a 1/4 inch circle. We'll just select that, and we'll just go to the center point, center point, center point, center point. And now we have tooled up all the circles. So now we need to do this outer edge. There's a couple different tools that you can use, but the first thing we need to do is we need to create a wire joint, and everything on the Trumpf has to have a wire joint. And so that is so that while this sheet is actually moving around on the machine, these parts don't get cut out completely and just go flying everywhere, get up under the head, cause a bunch of problems. So we'll manually place a tool, and on this one we use a trapezoid. And the reason for this, so we'll right click, and so you can so when we do this, it shows them the center point. You can go to the center point and it will just place it anywhere on this line. If you right click and actually get the center and the end, it will snap to the closest edge. And so what we want to do, since this is 060, is hit tab, hit tab, and it will come up to these boxes, and you want to put in an offset. This will offset this tool away from that edge. So I'm just going to put in a 0.015 for 16 gauge and hit tab. And now it's hard to see, but when you scroll in, you can see that it actually leaves a small gap between this tool, or this edge rather, this point, the start of this radius, and where the tool starts. So when we left click that, it will place that. And so if you visualize this sheet, this part is being left, it's not being cut. That's our wire joint. And doing it this way, this is a very strong joint since it has this angle to it. So we'll do the same thing on this edge. Go here, snap to that, and then left click, and it'll again leave the same edge. So that will actually hold that part into the sheet. Since this is such a small part, we probably only need to leave 2 wire joints. Larger parts obviously require larger joints. It's kind of a thing you just get a feel for. The operators will give you feedback if parts are hard to get out, parts are falling out, they may need more wire joints. In this case, they probably wouldn't need more wire. If these are falling out, they probably wouldn't need more wire joints. They would probably just need a bigger, thicker joint. So in that case, you would just delete these 2, come back in here, retool it with a 0.018, and then retool it up. This should be fine. 2 of these will be good, so we'll just leave it as is. So next, we're going to select the rectangle that we're going to cut this part out with. And since these radius, this custom size right here, this 1/4 inch radius is a 1/4 inch thick on this edge, I'm going to select a rectangle that's 1/4 inch wide. And the longest one we have is 1/4 by 2.5. And you always want to select the longest tool that you have to reduce the amount of punches it takes to cut this part out. That's going to speed everything up, less wear and tear on the machine, less wear and tear on the tools. Same thing, you right click it and you can snap to an edge, you can snap to a center point. And so we're just going to snap to a center point. And so when you look at this, it snaps to the center point of this line segment. And when I left click this, it overlaps that 1/4 inch radius, which is perfectly fine because we're going to cut this out first. So this is going to be a void area. So this little bit of overhang is not actually going to cut. So it can overlap tools. It's perfectly fine. Again, this side, the right side, will snap to the center point of this line segment. Left click it, it's done. So now we have a problem. This punch isn't long enough to punch this side out. So what do we do? So there's a icon over here, it's called a 2-point punch. Click that, and what Metacam does is once you have used a punch in this program, it highlights it blue. So you will go back to this 1/4 by 2.5 rectangle, select it. When you right click, it selects an edge, and this is the edge that is going to nibble out essentially. So on a rectangle, you're going to want to select the long edge. The reason for this is you select a start point, and then it kind of previews the tool. And then as you go along this line, it will select an endpoint, and you can see there's our tool, and then there's the rest of the path that it will cut out. So no matter how long this part is, we can just come through here and select the entire sheet. And so what that allows us is we don't have to manually place all those punches. It will automatically figure out what it needs to do with the proper amount of overlap to cut that line out. So we'll do the same thing with the bottom here, just like that. I'm selecting the mid part of this trapezoid to start at. And I'm just going to do the center point of this radius tool. Again, overlaps usually are fine, and they're actually preferred because if you go butt up right against the tool, sometimes it will leave just a little sharp nub. So when you overlap, it'll make sure that it doesn't do that. It produces a better part. And so as you can see now, it will leave this void area, and it will leave all that around there. So this part shouldn't come out of this sheet. It should stay in there and run perfectly. So the Trumpf doesn't have the ability to create a pattern at the machine. So we have to do that here. We have to create a layout. So after you are happy with this part, you will go to layout this part, and it will ask you to save this. I'll just back out. We don't have anything in the Trumpf folder. Let's see, wrong folder. So 8049. We don't have a Trumpf folder, so we'll create one. We'll go into the Trumpf folder, and we'll save this part in the Trumpf folder. So when it's saved, it will bring up this screen. Again, sheet size, these are where your clamps are, these are your margins. This one doesn't look bad. The usage looks fairly good. The yield's pretty good. but you can play with these numbers. This is, I think it's left, top, right, bottom. The bottom you can't change. The left, right, and top you can. You can go smaller, as long as it doesn't affect the integrity of the sheet. You can actually reduce that if you could get another row of parts. It doesn't look like we can, so I'm just going to leave it alone, but you could. Spacing, so the machine will automatically figure out the spacing for these parts. So it takes all the tooling in consideration, and it is putting a tolerance of 1/4 inch between each part, left and right, top and bottom. You can actually change this. So let's say if we were really close to getting another line of parts and we wanted to make it 0.2, you just delete the 5, and when you hit tab you can see it change. So let's put that back in there for a second. So right now we have 248 parts. If we delete the 5 and we hit tab, we actually got one more extra part. Let's do the same thing. So now when we hit 0.2, we got essentially 8 more parts on this sheet. So I don't usually like to go any less than 0.2. If you're really close, we could adjust the margins, we could do some things to really get it on there, but you have to be careful. If you cut out too much of the sheet at a time, it will actually make the sheet real flimsy, and it won't run well on the punch machine. So I'm going to go with this. We've got 257 parts on this sheet, so I'm just going to go ahead and hit OK. And so this is our layout. You can see the frame around it, the gap in between the parts. This is a pretty good layout. So now you want to go to your tooling tab, and then you want to table sequence this. So we're not going to individually, you can interact sequence, and you can pick the order in which you want these, but you don't want to do that, because what it'll do is it'll cut one part, so it'll punch the holes, then it'll switch tools, it'll punch the radius, switch tools, it'll punch the trapezoid, switch tool, punch the rectangle, switch tool, and then it'll go to the next one and do the same thing. It would be incredibly slow and just not good for the machine to do it that way. So when you table sequence, you're sequencing by the punch. So like right now, if we left it this way, the machine would go out and grab the 1/4 inch punch, and it would punch every 1/4 inch hole in the whole sheet before it switched to the next one. So this is the way you want to do a layout on the Trumpf machine. So we need to figure out which punch we want to punch out first. So we know we always want to cut the part out last, and so what that does is it gives you more sheet integrity, so that as the machine is moving the sheet around, it stays, it doesn't move around, it doesn't shift side to side and give you bad parts. So you always want to cut out the part last. So when we look at this, we're cutting out the part with this 1/4 by 2.5 rectangle. So what we can do is grab this rectangle. We want to grab, so when we select, we can select individual angles of that punch, or if we select the name of that punch, it selects everything for that punch. So we want to select everything on this rectangle. We want to move that all the way down. So you just left click it and drag and drop it to the bottom, and it will change it. Next, I like to cut either the trapezoid or the radius out first. And this machine is an auto-indexing machine, so it can actually turn these tools as it's punching. So right now, when it got to this tool, it would grab the tool in this angle and it would only punch at that angle. Then it would turn to 180 and only punch these tools that are 180. Then it would turn to 90 and only punch these tools that are 90, and etc., etc. What we want to do is merge all these angles into one tool path, so it does one tool path all the way down the sheet, and then it finishes. So you want to go to the last one in this group of trapezoids, click this gray button, merge with previous, so it will actually merge the 0 with the previous line, which is the 90. Now we have a bunch. It shows whenever you see bunch, it means that you bunched them together. So we want to do that again. You can either unmerge them or you can merge with previous again. So it'll merge this bunch 1 with the angle 180. So now we want to do that one more time. So we have one bunch. So when we click that bunch now, it actually tools this entire sheet when it has the trapezoid tool. And so I'm going to do the trapezoid first. I'm going to click it, move it above the circle, and let go. Same thing with the radius. We want to merge all of these angles. So just click here, merge with previous. Then we'll go to this bunch 2, merge with previous. So again, merge with previous. And so all of our radius are one tool path now, and I'm going to put that right above the circle. And then we'll leave the circle where it's at, because you want to do, if you had more slots or whatever it may be, you want to do those first. So you want to do all the interior holes before you cut it out. So your cut lines are going to be last. So now we have it in the order that we would like it to be in. So now we need to tool it how we want it to run. So we'll go to the trapezoid first. And in general, it's easier on the sheet and the machine if it doesn't just jump back and forth like it's doing now. If you can have the machine where it just goes in a straight line, punches, goes to the next row, goes in a straight line, it's much easier on the machine. The parts don't fall out. And so when you go here, you can actually select, do you want it to go up and down on the y-axis? Do you want it to go left and right on the x-axis? This one it's the LAA pattern. It'll do all the x's first, so it will actually punch in one direction and then it will stop, come back down to your start point and punch in that direction again. That one's rarely used. There's just very specific examples, mostly with forming tools, that I might would use that one on. And you can do the same thing in the X, and then back to automatic. So if you see an asterisk, that means you're letting the software decide. So this one I'm going to do left to right. And for the Trumpf machine, it punches, or it traverses much faster in the X direction than it does the Y. And so as long as it makes sense, you want to traverse the machine in the X direction as much as possible. So another thing is you can determine the start corner and the exit corner of the toolpath. Normally, if you're looking at the machine, the tools are located down here by the clamps on the lower left side. So just for saving a few seconds, I always do my start point on the interior tools like that on the lower left side, and that way when it goes to grab this tool, it only has to traverse a few inches and then it comes out and starts punching instead of rapid traverse across the sheet. Same thing with the next one, the radius. Click on it, again, we're going to do a left to right in the X direction, and we're going to start in that lower left corner. Same thing with the circle. Left to right, lower left corner. And sometimes if you have to determine if you have a lot of holes that are closer in the Y than they are the X, then you might tool it up and down on the Y versus the X. And the reason for that is, even though the Y is traversing slower, if the holes are closer together, you're still saving time. So this is about time savings. And then lastly, we're going to do the rectangle. So you always want to, whichever one of these you select, so this is 90 degrees, it's going up and down on the Y. This is 0, it's going left to right. Whichever one of these you want last, which will vary from part to part, you always want to end, so the exit corner you want in the lower right hand. And the reason for that is, once it finishes this sheet and stops here, it will actually shift this way to the left for them to unload on the machine. So again, it's just time savings. You don't want to stop on this side and the machine just rapid traverses the sheet left, and you may get parts falling out, flying out. So you always want to end your last line, whatever it may be, you want to end on this lower right hand corner. And so then we're going left to right with this tool, so it's just in a straight line going back and forth on the Y-axis. When it's doing 90 degrees, we want to go up and down, so you can see the toolpath change. So we're going up and down on the Y-axis. And so where do we start and stop? So on this one, we want to stop here close to the start of this one. So this one starts in this upper right hand corner. So I want this one to end in the upper right hand corner. So that way when it finishes here, turns to from 90 degrees to 0 degrees and starts punching again. And again, it's time savings. It saves a little bit of time. So after we're done, this looks good, exit out of that, and we will simulate this program. And when you have a lot of punches, a lot of real small parts, it takes a minute for the simulation to come up. And we're going to hit play, and this speeds it up to the fastest speed, which is still not that fast. But you can actually watch the toolpath and how it's going to traverse the sheet, and you can look at the tool of the angle of which the machine is turning that tool while it's running. So you can see it went back to that lower left hand corner of my screen and started this radius, and it started right there. And again, the reason for that is it's grabbing the tool in that corner, pulling it out, and it doesn't have to traverse the whole sheet before it starts punching again. it's going to grab the 1/4 inch circle, and you can see again it started in that lower left hand corner, and it's just going to go left to right on the x-axis while it's punching. And again, the reason why we go using the x-axis is just because the x-axis is about twice as fast traversing as the y-axis is, so it's much faster to do it this way. And as you can see, now it's cutting the exterior of the part. Before this, the sheet was, had pretty good integrity. As it starts cutting these, it will start losing some of the integrity. So you have to be very careful about. This is where you'd want to make sure that when you're doing your last cut, that you're moving from top towards the clamps. And the reason for that is as it cuts the parts out away from the clamps, that part of the sheet, once it's done with it, can actually move. It could shift a little bit as it loses integrity, and it won't affect the part because they're already cut out. And so, when you're cutting out parts and you're in your final step, you always want to move towards the clamps. So as you can see, it ended in that upper right hand corner, and it started the next angle in that upper right hand corner, so it didn't have to traverse the whole sheet. So that's where you want to make sure your starts and stops match up, just to save that small amount of time. So it's going to end in that lower right hand corner, just like we wanted to. Everything looked good with that, so we're going to eject and get out of this simulation. And I'm happy with this program. So I'm going to save it. Back in the Trumpf folder. You always want to create a folder so you can separate your program. So if you have a MITS or a Trumpf or a HOMAG or whatever it may be, you want to separate them by a folder. Part number's right, so hit save. Okay, now we want to generate the code. And it might take a second just because there's several punches. But what's going to happen is, when we go to this basic setting, there's two things that we may have to add. And you've got a nibble and a single. So what this is, it will actually have the machine dump out the slugs that it punches out. There's a chamber that has vacuum in it on the Trumpf machine, and it's got negative pressure in there so that the slug actually sucks away from the die so it doesn't get caught up. What will happen if you punch out a bunch of material, that chamber fills up, and then it'll actually cause a bunch of problems. So what you want to do is every so often you want to dump that chamber. And so this is what this is. So the difference between a nibble and a single. So a single is just one single punch. So when we look at this, we're looking at the circles, the trapezoids, the corner radius. Those are all single punches. And usually those aren't a problem unless you have just a ton of big slots or or something that's got a lot of material, usually you can get away with not dumping them, but we may end up doing a dump on the singles. The big one is the nibbles. And so as you can see, when we did that 2-point punch, that is referred to as a nibble because the machine is actually nibbling out that line. And so when we look at this part, the top is a nibble, the bottom is a nibble, the left and the right are punches because they're just single hits. It's just that one rectangle hitting by itself. So when we back up and we look at this layout completely, there's a bunch of nibbles and a bunch of that side left and right punches, and if we don't do a dump, you know, several times during the sheet, that chamber will fill up and cause problems and potentially could cause damage to the machine. So let's go back here. So what I'm going to do is, so you've got 1, 2, 3. Get this out of the way. So you've essentially got 21 parts in a row, and each part has 2 nibbles and 2 rectangular punches. So we'll do the nibbles first. So we want to end up with about maybe a quarter of this sheet before we dump. Maybe we'll do 2.5 rows. So if we have 21 parts, 2 nibbles per parts, that's 42 nibbles per row. So if we look at 1 row, 2 rows, that's 84, and then half again, so that'd be 84 plus 21, which would be 105. So when we go to this basic setting tab, we'll tell it for nibbles, every 105 nibbles, we want to dump them. Okay? So what about single punches? Well, again, we have 21 parts per row, 2 single punch large rectangles per row. So let's just do maybe like 150. We'll do 150 punches. So every 150 punches, it will do a dump. And again, this is very experience based. You definitely don't want them building up underneath the die if you can help it. Sometimes it'd be a good idea to err on the side of, you know, having more dumps and not causing damage to the machine. I would strongly recommend, while the machine is running, maybe looking at some programs you didn't tool up and kind of see what other programmers were doing and see what works. You can go out there and look at the conveyor belt and see the pile of slugs coming out from under it, and you know, then apply that to your programs, look at your programs and kind of mirror that. But again, this is purely experience based, but just keep in mind that if this builds up under the die, there is potential for damage to the machine. So I would always err on the side of caution. If you have large parts and it's punching very long segments, you may have to dump it every 15 nibbles or 12 nibbles. It just depends on the shape of the part. But in general, if you do, you know, a quarter of the sheet, you should be fine. But just keep that in mind. You may want to, on a new program especially, keep an eye on it, look at the size of the nibbles, and if they look too big, if you know, the piles are coming out, or if they're not coming out completely, that's another problem. If you get, when you're using long rectangles, if you know, when you're punching nibbles and it gets too many of them in there, they can get hung up in the chamber and cause issues. So again, it's always better to err on the side of, I'm going to put in, you know, an extra 1 or 2 dumps, you know, during a tool path, just to prevent damage to the machine. Once you have this and you're happy with this, hit OK. It will generate the code, We don't edit this code, so everything should be fine. Just hit save. Production, so you just want to go to production file, so you're in your Display 01 drawings. We're under our production folder, Trumpf folder, and just hit OK. One thing too is that the Trumpf always needs a setup sheet. So you've got a print button, you've got a print preview. We'll preview this and show you what this looks like. So when you print preview, it's going to ask you which report that you would like to generate. So again, layout Trumpf, we're in a layout. This is the Trumpf machine, so this is the one you select, hit OK. And so this is what it will look like. And the reason why you need this report is for the operator or the setup personnel that's actually putting the tools in the machine needs this information to know what tools are actually going in the machine and what the numbers are, so he can measure them and get them in the right spot. So with every program, you will need to print this off for the operator or setup personnel so they have this. It also gives you some useful information for job creation as far as how many parts you're getting per sheet, total time. You can go in there and figure out how long it would take per piece, so you can get a rate. So this is very helpful to several people. If you're ready to print it, you can hit print over here, or if you just want to print it, you can just hit the print buttons, select that, select the layout Trumpf report. It will then ask you which printer you want to print it to, and then you select, which printer you want, and we are done. This is a completed Trumpf program.